Now let's take what we've learned about radians and see if we can work some application problems involving distance and speed of something that involves a circular object, like a wheel. Let's think about a wheel that has a radius of 3 feet, and let's suppose this wheel is rolling down a hill at 2 revolutions per second. Now, let's think about the distance that this wheel travels in 1 revolution. Okay. Well, in 1 revolution, so 1 revolution, let's calculate that. Well, we just need to calculate the distance around the wheel. How much distance is around the wheel? Well, we've learned about radians, and we know that the circumference is 2 pi times whatever the radius is. And in this case, the radius is 3, so we have 2 pi times 3, and we have this, 6 pi feet. Whenever we make 1 revolution, whenever this tire makes 1 revolution on its journey down the hill, 6 pi feet are covered. Okay? Now, it doesn't cover, that's not, we want to know, what is the velocity per second? Well, it makes 2 of these revolutions. So this is 1 revolution and this is a half second. If we want a full second, remember this makes 2 revolutions per second, we have 12. This thing goes 12 pi feet per second because it's 2 revolutions. In other words, we're given the distance because we know how to calculate the circumference of a circle. So now I know this, that 2 revolutions per second. Okay, well, there's what we have. Now, that's after 1 second. Okay, 1 second. Well, let me do this. After 1 second, let's think about this. Think about the distance. After 1 second, we've gone 12 pi feet. Now, after 2 seconds, well, we've gone 24 pi feet. After 3 seconds, well, we've gone 36 pi feet. Because every second it picks up an additional 12 pi feet of distance. Now, the question might be asked, well, how long will it take for this tire to roll a mile? Well, remember, 1 mile is 5,280 feet. So we want to know, well, how long is it going to take? How many seconds is it going to take to get that far? Well, that's pretty easy to solve because we know that let's just do this. Let's just set up an equation. We know that every second we go an additional 12 pi feet. So think about this. We've got 12 pi feet, and we want to know how many seconds until that total is 5,280. So we can just solve that equation, and we get T equals 5,280 divided by 12 pi. In other words, every second we get 12 pi additional feet. So we're saying, okay, well, how many seconds are in there? How many 5,280? How many seconds until we actually get a mile? Okay, so let's go ahead and calculate that. And just simplifying this a little bit, we get 440 over pi. That's how many seconds. Okay, so in that many seconds, we're going to have 5,280 feet. Now, I want to point out something to you. We use this linear speed here. In other words, we looked at the rate at which this wheel is rolling down the hill in terms of, like linear feet. And we said this, that the speed of this wheel rolling down the hill is 12 pi feet per second. Okay? Because we're concerned about how many feet is that. Now, let's suppose we wanted angular speed. In other words, we're not interested in the distance the wheel is covered. We're interested in how fast is the angles changing. Well, every second. Now, when the wheel rolls around, when it makes one revolution, we have 2 pi radians. Okay? So every time this wheel rolls around, we get 2 pi radians. Every revolution. But this one makes 2 revolutions per second. So notice what we have. We have 4 pi radians per second. Okay? That's the angular speed. So notice the difference. When we calculated this linear speed over here, it was 2 pi times r. Well, 2 pi times 3. And then we had how many revolutions? Well, there were 2 revolutions, okay, per second. Now, notice this is 2 times 2 pi r. See? Revolutions per second, and this is the distance in 1 revolution. Now notice the difference in angular speed. In angular speed, we had 2 times 2 pi. Notice we just left off the r. That's the only difference in these two. So if you want angular speed, you just don't care about the distance. You just want to know how fast the angles are changing. So it's 2 times 2 pi. Okay? And this is just the number of revolutions per second, because we were concerned about revolutions per second. Yeah,